Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode, we're gonna continue our series and today we're gonna look at medium Earth orbit. So let's dive right into it. Now, first thing you have to understand, where does this begin? Now, if you remember correctly, I told you that LEO is very narrow band from Earth's surface. So basically, most of the LEO is very close to the surface. However, geostationary band, the band where you can exactly precisely match the rotation of Earth, basically your orbit would be exactly 24 hours. It's a very narrow band. So you have one narrow band on the lower end, low Earth orbit, and you have one geostationary. Now, in between, we classify as medium Earth orbit. So if you want that mathematical data, that would be above 2000 kilometers and below 35,000 kilometers. So basically, if it's not that you at 35,000 kilometer you would be orbiting very slowly, you still would be orbiting at 23 hours. Yes, and you, if you push it little bit further, you are more or less at the same band as geostationary. So the border here is not very absolute. However, in geostationary, the acceptable distance is very little, like it's very narrow. So is in basically LEO. So in between this side, LEO and GEO, you get MEO, medium Earth orbit. So that is the most useful band for satellites, and it is in very heavy use. So you can have in MEO, the orbits can range from 2 hours to take one orbit to 24 hours, almost touching geostationary. So that is MEO. But you have to understand, MEO is very dangerous simply because it is smack dab in middle of Van Allen radiation belt. So it is very dangerous. It's flat out not safe for human. If you have let's say like a moon mission or a Mars mission where you have to go through this, the only way to do that is go very quickly. Just go, like boost your rocket to maximum speed, have as much as delta V possible, and go as quickly as possible. Because if you can reduce your basically exposure time, basically how much time you spent in the radiation belt, you can survive. It will be like getting a CT scan. So that's how Apollo made it. And you can also have a radiation shielding, water bags and all that to improve your chances. It's flat out not safe for basically any sort of space station. We do not possess the technology that can allow to block that kind of radiation. Now, then when we are talking about electronics, you must understand, when we have electronics so small like modern electronics where we have transistors that are like 10 nanometer across, if even a random when you have radiation going through it, it can flip the bit would be flipped. So generally on Earth it's not an issue because we have thick atmosphere and we have magnetosphere. But when you are in the Van Allen radiation belt, your basically your memory will be corrupted regularly, randomly, and like you have to compensate for that. So we compensate in two ways. First way is we use radiation hardened electronics. So basically we don't use latest and greatest technology which is like very tiny, because tiny things are more vulnerable to radiation damage. So we make big thick electronics, like, and when I mean thick, I don't mean like it's a big vacuum tube. I mean the nanometer, we don't go for like 12 nanometer or 8 nanometer. We try to keep it at 2024. So that way we have more resilience, and on top of that the casing around it is also hardened. And then we have satellite shielding. Now that shielding is very complicated, it's complex, but all you have to understand, there are many ways. But due to the weight limitation, right now the best way is have multiple layers of different metals. So you will have one gold layer. Gold is very good at protecting against infrared. Then you will have aluminum, then you will have a plastic layer, then you have like a zinc layer. Different layers you will have, because it turns out instead of having one thick layer massing a lot, you can't protect against radiation. However, if your radiation has to go through multiple different elements, be it gold, be it silver or whatever have you, it loses its energy very quickly. So right now that is the best way to protect our satellite. And if you have good shielding plus radiation hardened material, you don't have to worry about it. Satellite is safe in this orbit, but you have to design for it. So those are the danger of it. So let's talk about the user's case scenario. Like if you want to study any navigation system, be it GPS, be it GLONASS, be it Galileo, be it G3, whatever there is, most of them are in MEO, basically medium Earth orbit. And there is one specific orbit that if done correctly, like as in 20,000 kilometer, you will get 12-hour rotation period. So basically you will go let's say I'm in India, the satellite will go above India 2 times in a day. So that is very useful for calculation of navigations. For that reason, lot of like GEO satellites and GLONASS satellites plus some Bindu satellites plus some Galileo satellites, all of them occupy this space. So most of the navigation satellite is in directly that place, 20,000 kilometer. Now of course it's not exactly that 20,000, because some are like 100 kilometer up, some are 300 kilometer down. So that band is in very heavy use. On top of that, it's also used for communication. I told you, like, most of our space is used for communication, and it also allows us very good basically geodesic studies, basically studying of the earth itself and space itself, because it's very not too far away where you have to like look at earth with a giant telescope, but not too close that you can't make out big features. Like, you will get good coverage. So it's a very effective band for use right now. And as you can see, this is a representation of how GLONASS, as in Russian GPS, works, and many satellites are there. And GLONASS is very good because of this, because they have coverage against pole. Like, if you go to North Pole or South Pole, GPS is not that effective. You go to North Pole or South Pole using a GLONASS system, they are very precise there. So let's talk about the economics of it. At the end of the day, it's all about economics. So I already specified LEO satellites are the cheapest. However, you have to have hundreds of them to get good coverage. Here, you need less than that. Let's say in LEO orbit, like let's say you set down a goal, like from point A to point B, data communication should have this much of redundancy, this much of bandwidth and all that. And it came up with, okay, you will need 100 satellites to have that coverage. You go to MEO, you only need 50 satellites. So reduce that count is reduced. Now you might be like, why not go to GEO directly? Let's directly go to GEO and be like, only need 3 to 4 satellites to cover the whole planet. Awesome idea, but geostationary is ludicrously expensive. On top of that, geostationary have what we call slots. So basically each country only gets few slots. India has a slot above it, USA has a slot above it, Japan has a slot above it. So you can easily get, like, there is not that much space left. So on top of that, satellite being expensive, you don't have infinite space. Like, there is no infinite space, but you have ludicrously large amount of space in low Earth orbit and MEO orbit compared to geostationary, because geostationary is a very thin band. Like some people say, like, there are only 800 to 900 slots where you can safely put. You can put bigger satellite, you can put smaller satellite, but to have safe operation matrix in every system, you have to have only 8 to 900 satellites. That's maximum. So understand that GEO is not cheap, and if you put a satellite there, you must get it insured, you must get it with like a lot of other things also have to do, and you must have a rocket engine in that geostationary. So once it's out of its operational lifespan, you can deorbit into graveyard orbit. To understand graveyard orbit, you can check my video about orbits here. So once you go there, then some other satellite will take its place. So you can understand GEO is very expensive, and getting license for GEO is no easy task. Now, when you are talking about MEO, you have a lot of option. I already told. Let's say for some reason you are like, you want to be at 20,000, and you are like, you know what, there are already GPS satellite, there is already GLONASS, and there would be a lot of interference. So you have to make sure your orbit is, you can narrow it down a little bit. Now it will affect your output, but it will still be manageable. Or you can be like, you know what, I can push it even higher, and instead of at 20,000, I'll be like 25,000. So there is a lot of room when you are talking about MEO satellite options. And then the final factor, why the hell people even want to bother with this, it's low latency. I already specified, when you are talking about geostationary satellite, they're good for television, but they are nowhere near good enough for good bandwidth or internet. If you try to do that, basically many of the secure website will flat out block you, because they cannot be basically the software algorithm freaks out when it's taking too long for pings to come back to. So for a safety reason, they will cut the connection. As you can see, like, you have point A to point B, going through wire, it's a very quick, but going to satellite is very slow. Now that geostationary is 30,000 one way, 30,000 another way, and that's happening from point A to point B. But when you have MEO, that's very quick. It can be as low as like 5,000 or 8,000 or to 20,000. That's also, now you might be like, that's only saving 20,000 kilometers. That still reduces a very severe amount of basically ping. Latency is very safe, and on top of that, because of inverse square law, you can check my video about that here. Due to inverse square law, your sensitivity improves, your energy requirement decreases, so it's win-win scenario. So that's the economics aspect of it. So what we can expect in the future. Now, many of you are familiar with Elon Musk wants to make a basically Starlink project, where we have LEO satellite constellation basically below MEO, and have a full coverage of the Earth. But as again, any of you have read the documentation, he needs 4,000 satellite for that. Basically entirety of Earth versus Elon Musk alone. That many satellite he needs. So this can be done. I have provided the link down below, a company that provides that. As of now, the company are very successful because they can provide fiber like speed. I'm talking 600 to 700 megabytes per second and latency is also very good. Your latency is less than 50 to 100 milliseconds, where Jio used to get 2 to 500 milliseconds. So understand this, flat out it's a tested technology, and it's very good for trunk connection. Understand, this is not meant for, Mio is not meant for you to pull out your satellite phone and have like, you know, data communication. It's meant for something like this, where you have people in remote area, military operation. That was the early adopters of this technology, and they will have a satellite dish and they will have the communication, because they are transmitting what we call intel, and that intel can be very big file. Let's say this is a surveillance file, it will be HD video file, and they would need to, you know, transmit it. They can't be like, yeah, that transmission will take 6 hours. It will happen if it's a geostationary. So they use Mio. Mio can transmit it in 2 minutes. So for trunk connection, where you have a lot of people using it and having one bandwidth going up and down, it's pretty amazing. So military installation, cruise ships, your jumbo jets, these places make excellent use of basically Mio technology. And on top of that, planes specifically, because they are above altitude, so they don't have to need as much signal strength as they will need to go through the atmosphere. It's pretty amazing use for current jumbo jet technologies. So we're gonna have low latency and high bandwidth, but be mindful, this is not appropriate for everyday use. It's not meant for you going out and like, okay, my mobile phone and I'm connected. It's not meant for that. Leo can do that, Mio cannot do that. But for a trunk connection like this cruise ship, which has the best internet connection on a cruise, you need this sort of situation. So there is a lot of hope in Mio orbits also. So this was my presentation on medium Earth orbit. I hope you liked it or learned from it. In that case, please leave a like, if and also click my ads shown in these videos. That will directly help me. And if you didn't like it, don't worry about it, you can dislike it. I would urge you to leave a comment, because I reply to all of them. Please subscribe, press the bell icon if you're free, and as always, thanks for watching.